find the eigenvalues and eigenvectors for matrix A. So here's the matrix A, and you ask to find eigenvalues and eigenvectors for it. So first of all, you need to find A minus lambda I. Okay, so basically you take matrix A minus lambda times the base matrix I in I lambda times I. Let me write it down for you just in case you don't know what lambda I is. So the matrix lambda I is lambda times matrix, the base matrix. Okay, so basically the I matrix is 1 0 0 0 1 0 0 0 1 1 in diagonal line, and you multiply that with lambda to get lambda I. Okay, so here's lambda I, then take A minus lambda I, you will get this. Then you find the determinant of A minus lambda I. So 5 minus lambda times cover this row and this column, cross multiply, cross subtract. So negative 5 minus lambda times negative lambda minus 9 times negative 1. Okay, and then minus negative 1 minus negative 1. Okay, cover this column and this row. So you have 0 times negative lambda, which is 0, minus 9 times 5. Okay, and then add 0 times, so this 0, because 0 times everything is 0. All right, so and then simplify this, you will get this. Okay, simplify it down, you end up with this, and then set it equal 0, then solve for lambda. You will get lambda equals 0, negative 4, and 4. Okay, so here's your eigenvalues. Now with these eigenvalues, you can find eigenvectors for it. Let's take a look at the first case when lambda equals 0. So lambda equals 0, plug it into here. Okay, and then find a matrix. So 5 minus 0 gives you 5, negative 1 0 0, negative 5 9, 5 negative 1 negative 0, which is 0, and then augment this matrix with 0 0 0. Okay, and then now let's see, you have this, if you notice, this matrix and this row and this row is the same, right? That means that you will end up with an indefinite answer, because 3 equations, but you have only you have 3 equations and 2 of them are identical, so you can solve for the unknowns. Okay, so if I multiply the first row by negative 1 and add it up onto the third row, I will get 0 0 0. Okay, and then rewrite the first and second rows. Alright, since I have indefinite solution here, so I have 5k1 minus k2 equals 0. For the second equation, I have negative 5k2 plus 9k3 equals 0. Okay, so for the first one, I can solve for k2 equals, which is equal to 5k1. For this one, I can solve for k3, which gives me 5 over 9k2. Alright, now if I choose k1 equals 9, if I choose k1 equals 9, that gives me 45. 9 times 5, 45 equals k2. So when k2 equals 45, k3 is equal to 25. Okay, so you can choose whatever value for k is, as long as it's not 0. Okay, so my eigenvector for lambda equals 0 is 9, 45, 25. This eigenvector can be something else. It depends on what value of k you choose. Alright, let's move on. So when lambda equals negative positive 4, you plug into this matrix, then you have this matrix. Okay, and then you augment it with 0. Alright, now let's take a look here. Alright, so since there are no, you have to do Gauss-Jordan elimination to see the relationship between k1, k2, and k3. Right, I have 1 right here, so what I need to do is to make the entries below 1 0. So I already have this 1 0. Now I need to make this become 0. Multiply the first row by negative 5 and add it up onto the third row. Negative 5 plus 5, 0. Negative 5 times negative 1, positive 5 minus 1, positive 4, 0 minus 4, negative 4, 0 0. Okay, now the next step is I need to make this become pivot. So divide the whole row by negative 9. That gives me 1, negative 1. Okay, and rewrite the first and the third rows. Alright, now this becomes my new pivot. So to make the next step is to make the entries above and below become 0. To make this become 0, add the second and the first row together. That gives me 1, 0, -1, 0. Okay, now to make this become 0, multiply the second row by -4, add it up onto the third row. 0, 0, 0, -4 plus 4, 0, -4 times -1 positive 4 minus 4, 0, 0, 0. Okay, now you see that you have 0 row. That means that you have indefinite solution. All right, so here's your indefinite solution. You have k1 equals k1 minus k3 equals 0. Then wait a minute. Oh, this is actually k3. So you have k1 minus k3 equals 0. Then k1 equals k3. Okay. Now k2 minus k3 equals 0. Then k2 also equals k3. Okay. So if I choose k1 equals 1, then k2 equals k3, which is also equal 1. Then my eigenvector for lambda equals 4 is 1, 1, 1. Right, now you're going to do the same thing for lambda equals -4. Okay, so plug lambda equals -4 into this matrix. That gives you this matrix down here. Okay, and then you work it out to get the 0 row. Okay, so for this one I keep the first. This is my pivot. I didn't divide it by 9 to get 1. Just keep this row and then rewrite the second row because we already have 0. Now make this become 0. Multiply the first row by -5/9. Okay, -5/9. Add it up onto the third row is 0. -5/9 times -1 positive 5/9 minus 1 -4/9. 0 plus 4, 4. Okay, now over here, this is my new pivot, and I need to make it 1. So multiply this row by -1. I have 1, -9. Basically, we just switch the sign of the row, the value of the row. All right, now make the top and the bottom value 0. For the top one, multiply this row by -1. Add it up onto the first row. So we got 9, 0, -9, 0. For this one, multiply this row by -4/9. Add it up onto the third row. You got 0, 0, 0. All right. Now, since you have an indefinite solution, I have 9k1 minus 9k3 equals 0, which means that k1 equals k3. Over here I have k2 equals 9k3. So if I choose k1 equals 1, then k2 equals 9, k3 equals 1, then my eigenvector for lambda equals -4 is 1, 9, 1. Okay, so that is your final solution.
If you find the video is helpful, feel free to give it a like, share, and subscribe to my channel in order to receive the most current videos. Don't forget to hit the bell so that you won't miss anything. I'll see you next time.